Okay, now one of the big things we want to do with these is we want to combine these inequalities. Okay, and the reason we might want to combine them is that these inequalities often are telling us about some quantitative relationship that we have out there. And so, for instance, I don't know, we could let x equal the number of llamas that we wish to have. I don't know why it'd be llamas. Oh wait, two L's. The number of llamas. And y maybe, who knows, the number of goats. Something like that. Well, and it could be that what we know is that we only can afford to feed at most, something like maybe 5 animals, and so we can feed at most 5 animals. And so I can write that algebraically as, well, the number of llamas plus the number of goats has to be less than or equal to 5, because you see it's at most 5 animals. So x plus 5 has to be less than or equal to 5, or x plus y has to be less than or equal to 5. And we could also have something else that says, well, I kind of like llamas better than goats, I guess, or something like that. And so I might also say I always want twice as many llamas as goats. Why? I don't know, but sure, we'll go with that. So now, what does that say? Now, we've got to be careful with the numbers here. So if I just read this, I might say, okay, twice, I want, at least, we'll say, at least, that makes it an inequality, twice as many llamas as goats. And so, now you might read this and you first say something like, I read this, 2x, because that's twice llamas, and that needs to be greater than the number of goats. Okay, now let's check that out and see if we wrote that correctly. So if, let's think about something that would work for that. I want 2 llamas and 1 goat. That works for that. That's at least twice as many llamas as goats. And so that means x equals 2 and y equals 1. And we see that indeed this seems to have worked in this case, right? That we've got 2 times 2 is greater than 1. Okay, so that point would work. Okay, now if we had 1 goat and 1 llama, would it work? So we look at this and we say, well, if x is 2 llamas, y is 1 goat, I put those in, it worked. But what if we had x equals 1 llama and y equals 1 goat? Now let's check that to see if it works, and I would have 2 times 1 is indeed greater than 1. Well, that worked, except that's not right. right? This is incorrect because I don't have twice as many llamas as goats. And so actually what we need to make that one true is x needs to be greater than or equal to 2y. So see, this was all wrong. And notice then that this other still works. If x is 2 and y is 1, this still works because I get 2 greater than or equal to 2 times 1. That's true. But if I have x equals 1, y equals 1, it no longer works because I'll have 1 greater than or equal to 2 times 1. Nope, that's wrong, so that's wrong. That didn't work. And, you know, we can try lots of other things. But notice that you have to be careful when changing from English to algebra, in that, you know, what you really need to do is check that the numbers that you think make sense really do make sense in the inequality that we've written, or an equation if you're modeling with equations. And so in this case what we've got then is x plus y needs to be less than or equal to 5, and x, and I'm going to bring over the 2y, make it minus 2y, is less than or equal to 0. Oops, sorry, greater than or equal to 0. Right, greater than. And so I have these two lines, and so if I plot them, here's x, here's y. Now this first one's pretty simple. If I let x equal 0, I'll get y equal 5. And if I let y equal 0, I'll get x equals 5. And so I have that. And certainly I can be anywhere on this side because 0, 0, if I use 0 of each, that's less than 5 animals. Okay, so there's the first one. Now, here I have x minus 2y equals 0. Well, again, that's going to go through 0, 0. Now, we can go back up here. We did have another point that worked, right? If we had y equal 1 and x equals 2, that works, right? Y equals 1, x equals 2. So again, we just need to plot that proportional relationship. X equals 1, or sorry, y equals 1, x equals 2. So if that's about 2 and that's about 1, we would be here. And so that's that line. Now, which side of that do we need? Well, again, I could check if x is equal to 2 and y is equal to 0, does that work? I get 2 minus 0 is indeed greater than or equal to 0. So here we want this side. And so as we look at the combination of the two, what we see is actually this triangle is what we want. Now, why just the triangle? Actually, you could keep going and do all of this that was shaded by both. But we're talking about llamas and goats. I wouldn't have a negative number. So actually, I also know that x is greater than 0 and y is greater than or equal to 0. Sorry, greater than or equal to 0 for both of those. So again, you wouldn't really be wrong if you just took these two inequalities here and you started shading in all of this stuff that was overlapped by both. So if we check anything in here, any of those points will work for both. So, you know, if I go down here and I check something like 0, negative 3, I realize it's kind of hard for you to read there, but 0, negative 3, notice 0 and a negative 3 here, I get negative 3, that's definitely less than or equal to 5. And if I put in 0 and negative 3 there, I get a 0, and then negative 2 times negative 3 is 6. That's definitely bigger than 0. So yeah, that works. That works in both. But again, well, realistically, we probably want to toss that in. And so what we talk about in this case when we combine the two of these is this triangle, which we'll call our feasible region. Okay, and we can in your project you'll combine more than just two of them, plus some non-negativity constraints. So here we're saying these can't be negative. But here in this example, we will just do 2 because then it just starts getting harder to draw them all. But that's the idea, is that if I have 2 of these inequalities, I can look at their overlap and see what region is common to both. And typically, if these are constraints on my life somehow, like, well, I can't have more than 5 llamas, or or 5 animals, and I want at least twice as many llamas as goats, because wouldn't anybody, then here this constrained my life that way, and I am stuck with only solutions that are in that dark triangle there. Okay, so now it's possible you could have 2 regions that don't work together, and so for instance you could have something like, suppose we'll just take the x plus y is less than or equal to 5. So I can't have any more than 5 animals. But on the other hand, suppose in order to get a permit, I have to have at least 10 animals. And so I have that. Well, when you look at it, it seems pretty obvious. I can't do both. I can't add 2 numbers, get less than 5, and then also add those same 2 numbers and get greater than 10. And of course, what this would look like is, there's my 5s. But now when I go out here to 10 for each of these, well, again, when you look at the regions that go with these inequalities, here 0, 0 works, and so I shade in that side. But here 0, 0 doesn't work. 0 plus 0 is not greater than or equal to 10, so I can't be on this side. I have to be on this other side, and so there are my 2 regions, and they don't overlap. And so in this case, I'm out of luck. I could never find a feasible solution to both of these. And that happens sometimes, is that your constraints force you to not be able to do something. And here we can see it in a very nice picture with these 2 shaded regions that have no overlap and this big divide here in between. Okay, so that's the idea of combining these constraints. And we do that with our Module 4 project.